Before we get into the show, I wanted to put out a hiring call. I'm looking for my next software engineering apprentice, a young .NET programmer to help me directly with my work, building architectural prototypes, figuring out new patterns, tons of coding. And I'm looking for a .NET programmer whose hobby is also programming. For the right person, programming isn't work, it's play. And besides a job, I can guarantee that you will learn faster than you ever have before. And I will invest in your professional education and we'll work together and you will grow. You'll report directly to me. So if any of this sounds interesting to you, just send me an email or give me a call. Now, let's get into our show. Clean Code and How to Do Software Well with Uncle Bob Martin.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software engineering firm serving companies struggling with business-critical software projects. So when failure is not an option, ClearMeasure guarantees your success, and you can find them at clearmeasure.com. Quick announcement, we are in our second year of my architect forums, and signups for the next session, they're up on the website. And if you lead a software team and you're looking to collaborate with peer architect leaders, just sign up at the link in the show notes. It doesn't cost anything. It's just a conversation. And for those of you who are looking for Programming with Palermo, my video podcast, you can just search for it in any of the directories and you'll be able to find it. My guest today on the show is Uncle Bob Martin. If you don't already know Bob, he's a software engineer, instructor, a best-selling author. He's most recognized for developing numerous software design principles and for being a founder of the incredibly influential Agile Manifesto. He's the author of a number of clean code related books, including his latest, Clean Agile and Clean Architecture. And he reinforces Agile values and principles for a new generation of programmers and non-programmers alike. And in the past, Bob was also the editor-in-chief of C++ Report magazine and served as the first chairman of the Agile Alliance. And he's spoken at so many conferences, too many to list. The publications go on and on. He was last on the show, episode 105, a number of years back. We'll include a link to that in the show notes. And he's in the midst of continuing to talk and teach and write more books. But Uncle Bob, welcome back to the show. How are you, sir?
I am well. Thank you so much. It's good to be with you again.
Oh, my pleasure. My pleasure. We'll highlight the link to your past episode so that the listeners can go back and listen to that one where we dove into Agile and extreme programming. But a lot's happened since then. You're teaching more. You're speaking about your software brand, clean code, clean architecture. Before we kind of move on, I want to make sure the listeners understand you have a strategy around that, the word clean and why you've applied it to software. I'm curious if you give us a quick rundown on why clean, why you chose the term clean as something beneficial for software.
It's a word that kicked around for a very long time in the 80s and 90s, whether your code was clean or not. And I don't know if it stayed through the 2000s or not, but I was trying to figure out a new book to write. And I thought, I need to write a book about how to write code well. And I want to call it Clean Code, but that seems awfully arrogant. So I debated for a long time whether I should write the book, whether I should call it Clean Code. And then in the end, I thought, if I don't do it, somebody else is going to. So I might as well do it and take the bullet. And then ever since then, it was a fairly successful book. And so I thought, well, okay, let's just keep using the word clean and put out Clean Coder and Clean Agile and Clean Architecture and a few more of those. And I think that's probably the end of the word clean now.
Okay.
I think we've had enough clean titles. And the last book I did doesn't use the word clean at all. It's the last book is functional design, and then the next book probably won't have the word clean in it either. So I think it's time to draw an end of the clean series.
Got it. So with all of these books, are people still writing dirty software? It's inevitable, right?
Yes. People are still writing dirty software. Look, this is a long-term project for me. It's a way to try and dump 50 years of experience into a stream of developers that is doubling every 5 years.
Yeah.
And so that's a hell of a challenge, frankly.
Right.
And just trying to reach a fraction of them and trying to impress upon them the necessity of doing things well rather than doing things fast, because you can't actually do them fast unless you do them well. Those are very tough lessons, especially for people in their 20s.
I'm glad that you said it like that, because I think it's missed on a lot of people. Fast, well, and you can't go fast unless you do it well. Because I think a lot of managers who don't understand that relationship, they just push their development teams. Hey, we need to get this out. We need to get this out. And then the well or the quality is sacrificed. How do you think about that relationship, and why is it that way?
Well, managers are concerned about schedule and cost and things like that. That's what they should be concerned about. And most managers, even if they were programmers once in their life, as soon as you become a manager, that gets blown out of your brain.
Yeah.
And your priorities are cost and schedule and the commitments that have been made to customers. So that's what you're going to talk about. That's the pressure you're going to place on everybody. It is the developer's job to maintain quality. It's not the manager's job at all. You can't blame the manager. You can't go back and say, well, the manager never gave us time. No, it's not. That's not a legitimate excuse, right? It is the developer's job to realize that quality is very important, that quality is the key to going fast. Quality is the only way you go fast. And it's the developer's job to maintain that quality instead of pretending to go fast by rushing.
Mm-hmm. That's a good point. Pretending to go fast. We could mark something as complete, but it's not really.
Oh, yeah. That never happens, right?
That's right.
No, I mean, you can pretend to go fast. You can say that you're checking things in. You can say that, oh, it looks like it works to me. But you're just pushing everything towards the back end. You're pushing things into QA. You're pushing things into production problems. You're pushing things into all the delays that occur pre-production. And those can go very long indeed. So the best way to go fast, do a good job. You have to take your time to do a good job, and you will get done faster if you do that.
Yeah. You're also are you the sole creator of the solid principles? Or I don't know if you give credit to somebody else as well. Or you just codified them?
I'm definitely not the sole creator. Some of the principles I coined. Yeah. Others came from Bertrand Meyer, Barbara Liskov, and other people as well. I learned them from Jim Copleen. There's a whole bunch of other materials that fed into that. You could blame me for gathering them into a basket, and then you can blame Michael Feathers for realizing that they spell the word solid.
Okay, so Michael Feathers, then you give credit for the actual acronym solid.
Yes. Oh, yes. Yeah, he came to me one day and said, if you just change the ordering, the first letters spell the word solid. Yeah. Never knew that at all. I was teaching them in a completely different order.
Was it Saldi first?
It was, let's see, open close first, and then Liskov, and then single responsibility, and,
OLS, yeah.
It didn't spell anything.
Right. So for a long time, you've been passionate about helping others get better, and you've just done so much teaching of all kinds of sorts and publishing. So you've kind of got that in you. You said this is the last of the Clean series. What's your current book? What's your next step in trying to help developers do it well?
So the book I'm writing right now, and I just sent it to the publisher for review. is a book on the history of programmers. Is it seems to me that especially young programmers have no idea where they came from,
Mm.
or what life was like for programmers, say in the 1940s or the 1950s. And it's an interesting time. It's a lot. There are a lot of very powerful lessons to be learned by looking at the way those people worked and how they came about, how they solved the problems they solved. The book is about programmers. The computers are characters in the book, but they're in the background. The real story there is the programmers, and not just the technical problems they solved, but the personal problems they solved and the management problems they solved, and all the same, estimation issues and all the same stuff that we deal with today, but in a context that is, to quote Spock, stone knives and bear skins.
Okay. And so do we really know the first era of programmers? Or who did you identify as kind of like the initial trailblazers?
You can go way, way back in time, and you could say like the scribes of Egypt were kind of like programmers because they wrote the procedures of the civilization and they executed those procedures too. But I make a brief foray into that kind of discussion, but then very quickly settle in on Charles Babbage and Ada of Lovelace. Very interesting pair of, I'd say they were the first pair of programmers.
Oh, really?
They spent a lot of time trying to program a machine that would never be built.
Okay.
And they knew it would never be built, but they still spent all this time writing these. You'd have to call them programs, although you wouldn't recognize it as code. But writing down these steps and procedures, they invented the loops, they invented conditional branches, never got them implemented, never was able to see one implemented. The machine they envisioned was the size of 2 gigantic locomotives. It would have been driven by a fairly massive steam engine. He wanted to have 1,000 registers of 50 decimal digits each. Each of those registers would have been an assembly of gears that could have had 10 positions.
Wow.
And the 1,000 elements of data would be transmitted over a mechanical bus to a mill that would multiply and add and subtract and divide, and then the data would move back through the bus back into registers. And the instructions would have been punched on wooden cards with holes in them, like a jacquard loom. And these cards would have been assembled into a chain, and they would chunter along on the reader while the data moved this way and that way. You can imagine if that machine had ever been built, what it would have sounded like.
Yeah.
as it one after the next instruction was executed by these grinding gears. So very interesting thought experiment for the two of them. But remarkable people. Babbage was never able to finish anything. I think in his life. I mean, he tried to start a bunch of things. He was never able to complete anything. One of these guys, like a lot of programmers, where it's an old trite saying, the perfect is the enemy of the good.
Yeah.
He was constantly distracted by the next big design, the next interesting thing. He could never finish anything. He got a lot of money from the British government to build one computer. It took him 10 years, completely failed. They finally pulled his funding. He walked away with nothing. He'd put a lot of his own money into it as well. And then he went on to try and design even bigger and better computers, and never got anywhere. Fascinating.
Just the idea man, a theorist. A what if guy.
But nobody brought him back to ground. Nobody put him in the position where he had to finish something. Managers are good at that kind of stuff. He did not have a manager.
Right. I hear a lot, and I studied a lot of the late 50s era of programmers. And like, I think anyone who's gone through a formal computer science course probably has read Fred Brooks's work, The Mythical Man Month. Sure. And what have you in your mind carved off like the different eras of programmers and named them, or?
The way I organized the book was to organize it from about 1940 until 1970. And then the middle section of the book is 1970 to today.
Mm.
And that's my life.
Yeah.
That's my life as a programmer. I started programming in about 1970. So the format of the book changes entirely. It originally the first 50 years is stories about people in the past. And then the next 50 years is told from my point of view, looking out.
Because you remember it.
This is what was happening in the industry to me when I was doing this, I was doing that. And then the last segment of the book, which is the shortest, is to project into the future. What does all this mean for programmers in the next 50 years?
Mm-hmm.
How is quantum computing going to affect us? What about AI? What new languages are coming? So a fun little exploration to what might be.
Yeah. So in your research, did you see any inflection points in the number of programmers like we have in the last 10, 15 years? It's noticeable increasing, but are there any other decades that have inflections like that?
No, it was happening the entire time. And it was a cause of great fear. Initially, very, very early on, the machines were so primitive that you couldn't pay people to do the work.
Oh,
Nobody wanted to do it. It was horrible. John Bacchus said it was like doing hand-to-hand Mortal Kombat with a machine. And literally, these people were punching holes in paper tape in order to program the machines. Literally one hole at a time, right? That's the kind of level of primitivism they were engaged in. And debugging, of course, was a matter of weeks. And the machines were either they were mechanical. I mean, the very first computers in the 1940s were strictly mechanical machines with a couple of relays to help out, but they were gears and motors. And then later on, vacuum tubes came in, and then later on, transistors came in. And the number of programmers had to increase. It had to increase. And the only way to make it increase was to make programming easier. And that was Grace Hopper. Grace Hopper's mission in life was to make programming easier so she could hire more people, because nobody was going to be punching holes in paper tape. She needed to find a way to make it easier and easier and easier. And the problem with that is that the existing programmers said, yeah, but those programs are going to execute much slower. If you build a compiler, and in her day, a compiler was a really primitive thing. If you build a compiler, well, that program's going to execute more slowly. And that means it's going to cost more money, because computer time in those days was hundreds of dollars an hour or hundreds of dollars a minute. And so the emphasis was on saving as many computer cycles as possible, no matter how much it cost to program it. Because the cost of running it far exceeded the cost of programming it. And Hopper could see a time when that was going to invert.
Yeah.
And of course it did. It inverted within about 15 years.
Now, she was a Navy admiral, wasn't she? An officer in the Navy?
But she was an officer in the Navy. She had been a math professor. She started her career as a math professor, married, the whole thing, didn't have kids. But then Pearl Harbor happened, and she decided she was going into the Navy. So she left her husband, joined the Navy, became an officer, and they immediately sent her to Howard Aiken at Harvard. And Howard Aiken had built, with IBM's help, Charles Babbage's big computer.
Okay.
Without 1,000 registers, it only had maybe 50, but it was Charles Babbage's big computer. They didn't know who Charles Babbage was. They had never heard of Charles Babbage's computer, but they envisioned it again. Same kind of thought process. They built the damn thing. It's called the Harvard Mark I, a completely mechanical, you have to say electromechanical, but a completely mechanical computer that could do 3 additions per minute, and a multiplication took it 3 or 4 minutes. I can't remember the exact numbers. And again, it was driven by paper tape instructions. It didn't have jumps. It didn't have conditional branches, but they did loops. But taping the ends of the paper tape together and running it around in a
It was
loop.
a loop. It was an actual loop.
It was an actual loop of paper tape. Yeah. And she found the first bug in one of the relays, actually took it out of the relays and pasted it into her notebook, the first bug.
Was it a moth?
It was a moth, yes.
It was.
Mm-hmm.
And this was before she actually invented COBOL. Is that right?
Long before. This is like 1946, 44.
Right. But
1944-ish time frame. The war was still going on.
yeah, I think I remember her name as the inventor of COBOL or co-inventor of COBOL somehow.
She was certainly the driver of COBOL. She and drove it hard. Her goal was to get English into the language. A lot of other people wanted a Fortran-like solution. They wanted to have a mathematical language, and she didn't. And she fought it. She fought it so hard she threatened to quit over the whole thing, and eventually drove the English structure of COBOL into the language, much to my disappointment, because I think it's a terrible language.
Yeah.
I don't know if you've ever programmed in COBOL. I spent a few years programming in COBOL back in the early days. It's just awful.
So I think I'm
terrible.
at the end.
But that was her headspace.
Yeah.
She wanted to make it easy for people to program, business people. She wanted business people to program, and she thought English was the way to do that.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
I think I'm at the end of the era because I did take a college course at Texas A&M on COBOL. I was pretty good at it. I became the class tutor, and some of the sorority girls paid me to help them with their projects. And then I've had a few clients where, they had an old COBOL program, trying to figure out what to do with it, trying to bridge to that, CGI web service stuff to modern languages and the EBCDIC storage file. So I never did, large systems, but I learned enough to be dangerous and do some bridge work. But I think I'm at the end of the era of anybody who's actually taken a class in it, whereas you've done some serious stuff in it.
Well, I wouldn't call it too serious. I wrote a few programs in COBOL and then quickly decided I wanted to be an assembly language programmer.
Oh, much better.
That was like 1971 or something.
So that's at your publisher. And when do you think that we'll be able to get our hands on that book?
Probably in the fall sometime.
Okay. And then you're working on another book, right? That Keep Rolling. The functional.
I don't have another one in the queue. I just finished one, which is out now, which is called Functional Design.
Oh, that one's out now. Okay, but we haven't talked about that.
Oh yeah, that's out. Yeah, that one's out. It's available. You can go buy it.
Okay.
And that is the book that was a long time coming for me. I got involved with functional programming about 15 years ago because I got a wonderful book called The Structure and Interpretation of Computer Programs. And it was a book about written in the 80s, but it used Lisp as its basic language. And it just fascinated the hell out of me. I thought, I'd been a programmer for like 35 years at that point.
Yeah.
I didn't think I was going to learn something intrinsically new, but here's this book, and all of a sudden I'm learning all this very interesting stuff.
Was that the Ed Yurden book?
What's that?
Was the author Ed Yurden?
No, this is
okay. Different one.
I'm gonna think of it as Jay Sussman and where's that book? Anyway, you'll find it online. If you take a look for the structure and interpretation of computer programs, you will find it. And it's Sussman and something. I can't think of his name
Okay,
right now.
that's enough to find
Two
it.
MIT professors,
Right,
math
right.
professors, computer science professors. So I read that, and then I got interested in it, and I started doing my private projects in functional programming. Started using a language called Clojure, which is a kind of Lisp that runs on top of Java, written by Rich Hickey, by the way, if you remember him from the C++ days.
Clojure with a J, I remember.
Yes, Clojure. Yeah.
Yeah.
Clojure is Clojure. And so I got involved with that, and I started using it a lot. And then all my major projects, just started doing all of them in Clojure. And I did that for, well, about 15 years. And I learned a lot. And in the midst of all that, the functional things started happening in the industry, and everybody was doing Scala or F# or Haskell or something like that. And there was a lot of what I considered to be, to use a loaded term, misinformation. And I thought, the type of misinformation was things like OO and functional are completely different. They're mutually exclusive. You can't do OO and functional
Right.
at the same time, which was news to me because I was doing OO and functional at the same time. And then another piece of misinformation is design patterns are they were created because object-oriented languages are just so horrible, and you needed some way to work around all the horrible parts of them. And if you just use a functional language, then everything falls away and everything is lovely. And you don't need solid principles because you can just write functions instead. And I'm listening to all of this and thinking, well, no, I don't think that's true. And so I wrote this book, which is a book about functional programming, but from the point of view of a person who actually wants to do real work in the real world.
Mm-hmm.
How do you do this for real, right? And what does functional mean? And how seriously do you have to take it? And what are the principles of design? And what are the patterns? And I walked through the whole thing. And there's a lot of code in the book, and a lot of discussion of the principles and the patterns and so on.
Mm-hmm.
So a book for the practitioner who wants to learn how to do functional programming in a not just functional programming with OO and functional and procedural elements, and do it well.
Okay. We'll include a link to that as well. Because, yeah, you're right. Functions, I would think you just need encapsulation at every level, not just, everything's a function.
Yeah, no, that doesn't work particularly well. You still need an organization. You still need to manage dependencies. All the same things that have plagued us forever in software are still there in functional programming. Now, you get a lot of benefits out of functional programming. You get to control state much better. It's much better in a concurrent environment where you've got multiple threads running. And it's generally better anyway to not have loosey-goosey variables that are changing left and right. We've known that for years anyway. It's just that if you're doing it in a functional language, you've got this extra level of discipline that you can apply to that problem, and it just makes things better.
Yeah. Do you think it could be distilled down to like a set of simple principles, regardless of what type of software? Like, I heard one of them is no side effects or limit side effects. Or is there do you think a concise set of principles by which someone could say, yes, I have this mindset, I'm adhering to these as I write code, and that is, quote, functional?
I'm not sure that it works quite that way. There are some obvious things that happen when you're doing functional programming. For example, no side effects, right? Or at least you have to manage the side effects in a very disciplined way. I like to say that functional programming is programming without assignment statements. But I don't think it's quite as simple as a couple of bullet points and then you say, well, I'm a functional programmer.
Yeah.
I used to say this. Structured programming, I still say it. Structured programming is discipline imposed upon direct transfer of control. That's what Dijkstra told us, right? Don't use go-tos. Put some discipline around the way you jump so that you're not jumping hither and yon and going everywhere. And then I would say OO is discipline imposed upon indirect transfer of control, because what polymorphism really is just pointers to functions, right?
That's right.
And functional programming is discipline imposed upon assignment. So that's kind of my bottom line, reductive analysis of the last 50 years of programming paradigms. And if you embody that, if you bring that into your head and you understand it, then when you write code, you can write structured object-oriented functional programs without separating them, without knowing the difference. You're just writing code using these good ideas in an integrated way.
That makes sense. Well, no, I mean, I'm having you're a lot more years in programming than I am, but yeah, I remember starting with, okay, here's procedural. Oh, here's the go-tos. And okay, here's the, the functions and the loops and oh, here's the objects. And then, okay, here's the objects with limiting side effects. And then, okay. And now here's domain-driven design. And here's all these design patterns and the polymorphism and then the side effects by assigning it to an object. Oh, and then have some other code somewhere access and use that object. And then the debugging hell that results when things don't go like you thought they would. And the love of the garbage collector that you don't have to clean up all the memory that was allocated for that stuff. So, well, we'll make sure to include links to those books. Sure. And for the listeners who kind of their appetite is whetted and they want to follow you and learn more, you've got online video courses. What are all the other ways where developers can learn from you?
Oh, heavens. Yeah. So cleancoders.com, that's where all the videos are. And I've got, I think, 70 hours of video up there just of mine right now. There's other people that also put their training videos up there, but mine are about 70 hours, and it starts with the basics, basic, simple, clean code stuff, and eventually gets into principles, and it gets into patterns, and it gets into architecture, and it gets into functional programming, gets into all of that stuff. And it's like, it's several semester courses worth of material there.
Yeah, there's quite a bit. We'll include a link to that as well. And then as we close out, you've seen a lot, you've studied a lot, you've seen personally a lot. Fast forwarding or predictions into the future. In my career, I spent a lot of time figuring out how to make websites. Did some desktop programming, and then the .com era came around, figured out, okay, how do you make this website stuff? Well, now for a whole class of websites, I wouldn't even lift a finger. It's like WordPress. Nope. Do that with WordPress. Not going to custom code that, right? There's a whole class of software and just like CRM. Why would I ever write a CRM? Nope. Zoho, Dynamics, Salesforce, pick a product. What do you see as a trend going forward where, we'll still be programming certain things, but, other classes of software, they're just kind of being commoditized. Where's the shifts happening from your vantage point?
Well, I think the commoditization has been going on for a very long time. It gets larger and larger over time. There are bigger and bigger systems that we kind of commoditize, but that's simply because we have bigger and bigger projects that we need to integrate into and bigger enterprises that we need to integrate into. But I don't think that's a fundamental shift. It's just a normal growth. Yeah. We've been growing in that direction, and we will continue to grow in that direction. The big change that's happened is one that people are struggling against, and it's the loss of Moore's law. You and I probably remember when computer clock rates doubled every year or every 2 years.
Yep.
You couldn't keep a computer for more than 2 years because it simply wouldn't run the new software that was coming out.
Right.
And that stopped. That's gone. That stopped almost 20 years ago now, and people don't like it. They don't like that it stopped. They want it to keep going. Fortunately, density has continued. So we've been shrinking density down, but that stopped too, or it's about to stop. I mean, we've gotten down to the point where a wire is 20 atoms wide, and you just can't get much smaller than that. Right? So all of these, really fascinating hardware improvements are stopping. And the computers that are being made today are the computers that we will have 20 years from now and 30 years from now. They're not going to get massively better. And that is a startling change. We grew up with this crazy growth, nutty growth, exponentially growing, powerful machines. You can easily take one machine from 1960, say, and compare it to a machine today. And there's 20 or 30 orders of magnitude difference in the power of those machines. And that's a big number.
Yeah.
And that kind of number is not going to happen again, at least not with the given technology. And I don't see a new technology coming. So the big shift, from my point of view, is life on the plateau. You know, I went up the roller coaster. I climbed the mountain. The next generation is going to sit on the plateau. And there will be techniques and there will be things to learn, but it's going to be life living on with these machines that are still immensely powerful, but they're not going to be doubling every year. So we look out and we say, oh, my God, I mean, look at how far we've come from Tetris to Angry Birds. Life in 20 years is just going to be fantastic. And I think, well, probably it's not going to be much different.
Yeah. Well, I just recently gave some old iPads to my brother, and of course upgraded and tried to put the latest version of iOS on it, but he couldn't do the latest version. He just jumped a few, and they're dog slow running, a few versions up because all the little animations. And I'm thinking, are we wasting all of our horsepower with all these graphical things instead of the actual software?
Well, the marketing people don't think that's a waste.
But I do wonder from just building software systems that a lot of them just track data and crunch data and move data. And I mean, is there some genius in screen-based, keyboard-only, no mouse user interfaces? Like the coming back of why is Minecraft so popular? The graphics aren't great, but all the kids love it.
Oh, Minecraft. That's kind of virtual reality. It's gorgeous. But the game itself is just this open area that you can do anything you want in, and the rules are pretty easy to understand. I fell in love with Minecraft for a good number of years, and now I won't touch it because it'll suck away my life.
Oh, yeah. Well, I was thinking about the blockiness of it as opposed to, like the perfect rendering where it looks like it could be a real person. And like if we're on the plateau, what do you think are winning strategies, or is that just going to have to come out in due course?
Well, think of it like the airline industry. In the first 50 years of airplanes took us from the Wright brothers almost to the moon. I mean, they landed on the moon like 63 years after the Wright brothers. So 50 years, you're almost on the moon. But then the next 50 years has been a plateau. Improvements. But, 747 was built before we landed on the moon. That was in the first 50 years. Okay, now we got jets that are maybe a little better. But that's what the plateau looks like. Right? It's this evening out of the technology, and then the refinement of the technology, and the added safety and things, and cleaning things up and making them better, but without the crazy explosive growth.
So even more important to have software that you can actually change, that you can actually debug, that you can actually modify, and you're not stuck in the legacy code corner.
It's the period of refinement, the period of figuring out what we really are, right? So pilots in the early days, they just flew. And now it's like, okay, we need special equipment in the airplane, and we've got to have, safety rules for this and that. And there's all this refinement of operation, which turned air traffic into a relatively risky operation to one of the safest ways of transport that we've ever had.
Yeah.
And I hope that happens with software.
Yeah. Well, with more and more things having chips that are running lines of instructions. Yeah, we need to have
everywhere around you, everywhere. They're in the walls. They're on your belt. They're in the cars. They're everywhere around you. Millions of lines of code that drive our civilization. And we're going to have to get some control over that.
Right. Yeah. Listening to a briefing by the Wilderness Labs group, and they were showing that the IoT market is growing at a hockey stick that dwarfs the mobile market.
Yep. Because, why wouldn't you put smart things in everything?
Yeah.
They're dirt cheap.
Right.
Why wouldn't you put them? Now, you need a lot of programmers.
Yep. That's true. You need a lot of programmers, and you need ways to just get things out quickly. And so, awesome. Well, we're going to include everything we talked about, the links in the show notes. Is there anything that you want to throw in there as we close out?
Oh, heavens. Programmers, do a good job, guys. You'll go faster if you do it well. always avoid the temptation to rush. Kent Beck said it best. First make it work, then make it right. Don't forget that second part.
Make it work, then make it right. Yeah. And I always thought in my head, make it work, and then you can make it fast. Which is make it right.
The third thing in Kent Beck's little
then make it fast
sermon.
Awesome.
First make it work, then make it right, then make it fast and slow.
Got it.
No, fast and small. Sorry, not
fast
slow.
and small. That makes sense. That makes sense.
Yeah.
Awesome. Well, Uncle Bob, thanks for coming on the Azure DevOps podcast and catching us up.
Pleasure.
I appreciate it. All right. And dear listener, until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.